Let's begin by understanding a basic principle of motion. According to Newton's first law of motion, an object will remain at rest or continue moving in a straight line at a constant speed unless an external force acts on it. This means that without any force, a stationary object stays still, and a moving object keeps moving in the same direction and at the same speed. Contact and non-contact forces. Forces can be categorized as contact and non-contact forces. Let's break down the differences. Contact force. This type of force only occurs through direct interaction. For example, a car moves forward when pushed from behind, or a boy kicks a football to make it move. Contact force requires physical touch. Muscular force is a contact force applied when we push, pull, or lift objects. Non-contact force. Non-contact forces, however, act without direct contact. Examples include gravitational force, magnetic force, and electrostatic force. For instance, a magnet attracts iron nails without touching them. Similarly, objects fall due to the gravitational force of the Earth. Frictional force and its role. Now, let's talk about friction. Friction is the force that opposes motion between two surfaces in contact. Imagine you push a ball on a table. It rolls but soon slows down and stops due to friction. Without friction, the ball would keep moving. Friction also helps us walk without slipping and is essential in daily activities. However, reduced friction, like a slippery surface, can make us lose balance easily. Balanced and unbalanced forces. Forces can be either balanced or unbalanced. Balanced forces. When two forces of equal strength act in opposite directions on an object, they cancel each other out and the object stays still. Think of a tug-of-war where both teams pull equally and the rope doesn't move. Unbalanced forces. When one force is stronger, it causes the object to move in the direction of that force. For example, if one team in a tug-of-war pulls harder, the rope moves towards them. Similarly, if two people push a box in the same direction, the box moves more easily. Inertia and types of inertia. Inertia is the tendency of an object to resist changes in its state of motion. There are three types of inertia: inertia of rest, inertia of motion, and directional inertia. Inertia of rest. An object at rest will stay at rest unless a force is applied. Inertia of motion. An object in motion remains in motion in the same direction unless acted upon by a force. Directional inertia. An object moving in one direction resists changes in that direction. A common example is when passengers in a bus feel a forward jerk if the bus suddenly stops. Force and pressure. Relationship. Pressure is defined as force applied per unit area. Mathematically, pressure equals force divided by area. The unit of pressure is Pascal, or Pa. If the same force is applied over a smaller area, the pressure increases. For example, a sharp nail penetrates wood more easily than a blunt object. Pressure is also exerted by liquids and gases. Liquid pressure. When water is filled in a bottle with holes at different heights, water jets farther from the lowest hole, showing that pressure increases with depth. Gas pressure. Gases also exert pressure. When air fills a balloon, it presses outward on the balloon walls. Atmospheric pressure is the force exerted by the weight of the air surrounding the Earth. It's highest at sea level and decreases with altitude. Buoyant force. When an object is submerged in a liquid, it experiences an upward force. This buoyancy makes objects feel lighter in water. If this force is greater than the object's weight, it floats. Otherwise, it sinks. Archimedes' principle explains that the buoyant force on an object is equal to the weight of the liquid it displaces. This principle is applied in designing ships, submarines, and instruments like hydrometers. In summary, understanding the different types of forces, inertia, friction, pressure, and buoyancy, helps us see how objects interact with their surroundings, whether they're moving or at rest. From everyday actions like walking to scientific applications like shipbuilding, these principles form the foundation of how we understand and work with forces. Make the background music interesting.